What's up, math fans? I hope you're not scared of fractions because this episode is about fractions. So, I want us to be able to solve equations that have fractions in them. But if you are nervous about fractions, usually a fraction is some kind of term or an expression over another term or expression. Numerators on top, denominators on the bottom. Back in third grade, when you first learned how to add fractions, you learned, hopefully, that you add the top and keep the bottom as long as you have a common denominator. Usually when you learn fractions, you talk about pizza pie and you cut it into slices, but the slices have to be equal slices. You can't have a sixth of a slice added to a ninth of a pizza. It's not the same size slice. So in order to create the same size slice, you have to create a common denominator. So they teach you a method to find a common denominator. There's a bunch of different ways, you probably learned it. The easiest way is you just multiply the two numbers together. So my denominator here is 6, my denominator here is 9, so my common denominator might be 54, but there's actually a lower, or what's called a least common denominator. And in order to find that least common denominator, you want to find the least common multiple of the denominators, the smallest number you can think of that they both go into. Not a number that goes into them, not 3. I know 3 goes into 6 and 9. That's a factor. I want a number that they both go into. So I'm going to count by 6's in my head, I'm going to count by 9's in my head, and I'm going to come up with a common multiple, also known as a common denominator. All right, so I'm looking for the least common multiple of 6 and 9. So if I count by 6's, I got 6, 12, 18, 24, etc. Count by 9's, 9, 18. Oh, wait a minute. Did I say 18 twice? So my goal is to create 18's. So then you got to do a little thinking. Well, how do I make a 6 into an 18? I have to cut each slice into thirds. Basically, I'm multiplying by 3 over 3. And you're allowed to do that because 3 over 3 is really 1. Multiplying by 1 doesn't change the value. So I'm keeping the value, I'm just making it look different. So 3 over 18 is the same as 1/6. It's just skinnier slices, but it's the same amount. And here, multiply by 2 over 2, and I get 2/18, and then you can add straight across to get your 5 out of 18. The denominator stays the same. So that concept of common denominator is going to carry on over here when I get to 2 and 3. Number 1, there's a 5 as a denominator and there's no denominator here. If that bothers you, you can put the 4 over 1, but that's not necessary. What I actually want to do is get rid of the denominator. So if you notice, the denominator means divided by 5. I'm going to do the inverse, which is multiply by 5. So I'm going to multiply by 5 on both sides of the equation. Whatever you do to one side, in order to keep the equation balanced or equivalent, you do to the other side. And I explained that way back in one-step equations. So what happens is if you take something divided by 5 and then immediately multiply by 5, the 5's become irrelevant and it's just that original something that will drop down. 2x plus 6 equals. And I explained that also in my one-step equation video. So here, that 1 wasn't necessary because this is -4 times 5. Nothing's going to cancel, and that gives me -20. And now we got a two-step equation, so that is automatic. What is that? -26 divided by 2, and x equals -13. All right? So the goal here is to get rid of the denominator. That was easy because there was only one denominator. What if there's multiple denominators? Then that's what you want to think about. If I want to get rid of a 2, I multiply by 2. Now, do I do it on both sides? Where do I do it? To keep an equation balanced, you do it on both sides. But what happens is when you do it to this side, you have to distribute the 2 to all terms. So you have to put a times 2 here, and a times 2 here, and a times 2 here. Now plan ahead. Then I'm going to want to get rid of a 3, so I'm going to have to do times 3, times 3, times 3, times 3. Then I'm going to want to get rid of a 4, so I'm going to have to do times 4, times 4, times 4, times 4. Whew, that's a lot of steps. So some lazy mathematicians, not really lazy, this is actually makes more sense to us, is plan ahead and realize to get rid of all of them in one shot, you multiply by what's called the least common denominator, or the least common multiple of the denominator. So think of what does 2, 3, and 4 all go into. They all go into, looks like 12. So I'm going to multiply all of them by 12, by 12, by 12, and by 12. This says times 12, okay? Not an R, times 12. All right, so what is the point of that? I know that this and this and this all go into 12. They're all factors of 12. 2 goes into 12 6 times, leaving you with 6 times 8. 3 goes into 12 4 times, leaving you with 4 times 8. And again, look at that. POOF. 4 goes into 12. I actually used to call this method the POOF method. 4 goes into 12 3 times, leaving you with 3 times 8. And here, nothing's going to cancel. Don't tell me 12 goes into 26. Nothing cancels because they're both on top. So figure out what 12 times 26 is. I don't know either, so I'm going to actually do it. 18, 5, 26, 8, 11, 318. Please check my math. Should be 318. Now it's just an equation that I have to solve. And how do you solve? I think I combine like terms, and I get 13a equals 318. I'm going to divide by 13 on both sides, and a equals 318 divided by 13. Get yourself a calculator, you got yourself an answer. Let's look over here. 3 denominators. Again, I want to find my least common. Good thing it's the same thing, same one. So here I got 12 again, times the entire term by 12, times the entire term by 12. And this is interesting because there's a minus sign there. Times the entire term by 12. Here, because they all have a denominator, stuff is going to cancel all over the place. 4 goes into 12 3 times, 3 goes into 12 4 times, 2 goes into 12 6 times. Multiply what's left. So this is 3 times y plus 2 minus 4 times y minus 3 equals 6. And if you saw my video on distributive property, well, you're going to do it twice, here and here. So we got 3y plus 6 minus 4y. Negative 4 times negative 3 is plus 12 equals 6. And then there's a couple of different ways to solve this. I'm going to combine like terms. So I have 7y. I hope you can still see this. If not, you should be writing it. 7y plus 18 equals 6. So if 7y plus 18, this is from the last question. If 7y plus 18 equals 6, and then I subtract 18 on both sides, I get 7y equals negative 12. And then, oh man, I get a fraction. So what? I'm not worried about it. Whatever 12 divided by 7 is. And again, you can just leave it as negative 12 over 7. No problem here either. Okay? So I would write y equals negative 12 over 7. You might have learned it another way, which is fine. There's a couple of ways to do this. Some people say, I don't want to cancel. I actually like fractions, and what I'm going to do is create a common denominator. So you remember what I did here when I added my fractions? Created a common denominator and actually added them? Some people teach you, create a common denominator here and actually add the fractions. So they would turn this 2 into something over 12. And then they would turn this 3 into something over 12, and this 4 into something over 12. I think that just adds steps. I would not do it that way. That's fine. Other people look at this thing and they say, we don't like that method. We actually want to cross multiply. Another effective method. Whatever works for you. All right? Thanks for watching. See ya.